Hello students, welcome to Magesh classes. In this presentation we are going to discuss about plus 2 chemistry volume 2 hydroxy compounds and ethers short answer questions. The question number 7. Can we use nucleophiles such as ammonia, methoxide ion for the nucleophilic substitution of the alcohols? In general, nucleophiles are in the neutral or in the negative charge. Here ammonia is a neutral species and the methoxide ion is a negative species. It is neutral. And the methoxide ion, it is negative in charge. What is the role of nucleophiles in nucleophilic substitution? In case of alcohol, say example CH3CH2 OH ethyl alcohol. When it is treated with the CH3O minus nucleophile, whether this methoxide ion can be used as the substitution of this OH ion or not. So this is the question. Whether this ammonia molecule is used as a nucleophile to substitute the OH minus ion. This is the question. If these nucleophiles are better than OH, this can be used as a nucleophile here. When you compare the nucleophilicity order, the negative charged species are more nucleophiles than neutral species. For example, in case ammonia, it is a neutral species, and OH minus already in the leaving group present in the alcohol. Here the OH ion is a better leaving group than that of the ammonia species, because ammonia is a neutral. Okay, so ammonia cannot act as the nucleophiles. Here ammonia cannot act as a nucleophiles. When you compare the methoxide ion and OH minus ion, which one is a better nucleophile? The methoxide ion is a better nucleophile. Here one difference is here the oxygen hydrogen is attached. Here the oxygen, the methyl group is attached. Both are having the negative charge. Here the methyl group, we have studied that it is a electron releasing group by the plus I effect. So the charge of the electric density of the oxygen atom on this methoxide ion is greater than that of the OH minus ion. So it is better leaving group. So here the question, the methoxide ion act as a nucleophile in the case of substitution of OH minus ion. So what is your answer? In consolidation, ammonia is being neutral. It cannot be used as a substitution for the alcohols. And methoxide ion is better nucleophile than OH minus ion. So it can be used as a nucleophilic substitution for the alcohol. Clear? Here the nucleophilicity, higher nucleophilicity can be replaced the other negative species. So this is the basic. Okay. Next, question number 8. Is it possible to oxidize tertiary butyl alcohol using acidified dichromate to form a carbonyl compounds? Tertiary butyl alcohol having the structure, when it is acidified dichromate is a oxidizing agent. Our question is it possible to oxidize tertiary butyl alcohol using acidified dichromate to form a carbonyl compounds? In normal condition, it is not possible. The tertiary butyl alcohol is not oxidized by acidified dichromate. What is the reason? Because the absence of alpha hydrogen in it. For the oxidation, it is nothing, it is a removal of hydrogen. See here, the OH group contain oxygen, but in the alpha carbon, there is no hydrogen in it. So it cannot be oxidized. But it is possible when under high temperature. When high temperature is applied, what happens? The carbon-carbon bond is cleaved. As a result, what happens? You get the product CH3 here. One hydrogen is removed from this carbon. So you get the product isobutylene. Further on oxidation, it gives The carbon-carbon bond is cleaved here. You get the product CH3, C double bond OCH3. This is a carbonyl compound. And the fragment is oxidized to give the formic acid. Here the carbonyl compounds having one carbon less than that of the tertiary alcohol. So what is your answer? Is it possible under high temperature? In normal condition, it is not possible because the absence of alpha hydrogen atom. Under high temperature, what happens? The hydrogen atom is removed from the methyl group, so you get the alkene product. Here we can say, instead of oxidation, this compound undergo dehydration. That is, the water molecule is removed. In general oxidation, what you get? Hydrogen is removed, but here under high temperature, water is removed, you get alkene. Then the carbon-carbon bond is cleaved to give the product ketone with one carbon less than that of the parent alcohol and the byproduct formic acid. Next one. Question number 9. What happens when one phenyl ethanol is treated with the acidified K1O4? One phenyl ethanol. The formula is, this is the phenyl part and this is the ethanol part. See, this is the ethanol. CH3, CH2OH. In the first carbon of the ethanol, the phenyl group is attached. So it is called one phenyl ethanol. Okay. So this is structure. Phenyl ethanol is treated with acidified K1O4. What happens? It is an oxidizing agent. It oxidizes. So this is a functional group. That is nothing. Removal of hydrogen. Two hydrogen atoms are removed. You get the product like this. The carbonyl compound. Here double bond O, CH3. This compound is nothing. It is acetophenone. It is a carbonyl compound, ketonic compound. Methyl phenyl ketone. IUPAC name acetophenone. Next one, write the mechanism of acid catalyzed dehydration of ethanol to give ethane. Acid catalyzed dehydration of ethanol in the primary alcohol, the dehydration follows a E2 mechanism. So for the 10th question, it follows E2 mechanism. E2 mechanism means it is a bimolecular elimination reaction. The mechanism is nothing. The ethanol molecule CH3, CH2OH, here it has lone pair electron. When it is treated with sulfuric acid, concentrated sulfuric acid, what happens? It has H plus HSO4 minus ion. The H plus ion is go to oxygen, gets protonated. You get the product CH3, CH2OH, H. So by replacing one, you get positive charge here. So because of the positive charge here, it abstracts this electron to the oxygen atom. Here one hydrogen atom. When you write this CH3 like this, C, H, H, H. So here the electron is abstracted so that this electron goes here. So it removes us H. Okay. So you get the product CH2 in the first carbon. It will be double bond. And here this bond is broken. So you get the product CH2 and the water molecule. Here the one removes as a H plus. So this is a elimination reaction. So this is a mechanism. So it follows E2 mechanism. And the H plus ion is protonated in the ethanol molecules. Here the two molecules are involved in the rate determining step, and so it is a E2 bimolecular elimination reaction. After that, the protonated species are unstable. What happens? As it is positive charge, it abstracts this electron to the oxygen atom, so this bond is broken as OH minus. So here the electron is shifted from this hydrogen to here, so it is CH2 double bond CH2 plus H2. Okay, students, after this we have stopped this presentation. Thank you for watching.